Assalamu alaikum. We know when a charged particle moves in a magnetic field, it experiences Lorentz force. In this video, we will get the expression for motional emf using Lorentz force. For that, I consider a conducting rod AB of length L. Here, length of this rod is L. This conducting rod AB of length L is placed in a uniform magnetic field B vector, which acts perpendicular to the plane of the board in the inward direction. Here, this magnetic field is represented as B vector, which acts perpendicular to the plane of the board in the inward direction. Remember this. Now, this conducting rod AB, whose length is L, is made to move with velocity B vector in this direction, towards the right side. When it happens, the free electrons present within the conducting rod will also move with the same velocity, that particular direction. As a result, they experiences Lorentz force. As we know, any charged particle, when made to move in uniform magnetic field, it experiences Lorentz force. Now, the Lorentz force is experienced by these free electrons is represented as FB vector, which is equal to the product of minus E, which is the charge of the electron, multiplied with the cross product of V vector and D vector. Here V stands for velocity with which the rod moves, and the D is the magnetic field. I take this as equation number 1. Here the action of the Lorentz force is to accumulate these free electrons at this end. As a result, large number of electrons, free electrons, accumulate at E. So it becomes negatively charged. And here the number of electrons decreases, so it gets opposite charge, that is, it gets a positive charge. So because of this, a potential difference is created here in the rod. Due to this potential difference, an electric field is produced in it, which acts in this direction, in the downward direction, from B to E. This is the direction of electric field in the rod. Now, along with the magnetic field, the electric field also acts on these free electrons. So these free electrons experiences electric force, which is represented as Fe vector, and is found to be equal to the product of charge of the electron and the electric field, that is E vector. Here we have minus sign to show that electrons carry negative charge. Right? I take this as equation number 2. Here the accumulation of free electrons at the point A will take place till these two forces becomes equal to each other. Till they attain equilibrium, this phenomenon will takes place. Now at equilibrium, what happens at equilibrium? At equilibrium, magnetic Lorentz force will become equal to the electric force. If it is so, now I am going to substitute their values from equation 1 and 2. I will get equal to so. So to minus E vector this side, minus E vector plus B vector is what the matter. Now I am going to take their magnitude. We are taking the magnitude is written this way. This is a modulus which represents the magnitude. of a given vector quantity. Modulus of minus E multiplied with V vector plus B vector is found to be equal to modulus of E vector capital E modulus of minus E multiplied with E vector. Here similar terms will cancel. Minus E and minus E will cancel, and what remains is nothing but this modulus of B vector cross B vector modulus of this. Now this can be written as, we know when two vectors are in a cross product, then they can be considered as VB sin theta, and this is written as E. I have taken only the magnitude. Clear? And here theta is the angle between velocity and the magnetic field, and it is found to be equal to 90 degree. So theta is taken as 90 degree. It is so sin of theta equals to sin of 90, and lesser of 90 is nothing but 1. So here we get VB sin of 90 is equal to E. Here sin of 90 is what? It's nothing but 1. So the next step we get VB is found to be equal to capital X. There is small V. I box this. This relates the electric field and the magnetic field. Clear? Now, next, the potential difference in the rod is found to be V is equal to the product of electric field and the length of the rod. This we have studied in electrostatics. Now, here I am going to substitute the value of E. So what I am going to do, because of E are right. VB then L as such. Now, this potential difference creates EMF in the conducting rod. This is responsible for EMF, the conducting rod, and this EMF is represented as epsilon, which is found to be equal to VBL. Here V stands for velocity with which the rod moves. This can be rearranged and written as BLV. This is the final expression that represents the EMF produced in the rod AB. Now, this EMF is named as motional EMF because it is generated due to the motion of the conducting rod AB with some velocity. Now, suppose this conducting rod is connected to an external circuit. In that case, a current will flow in the circuit, and that current is taken as I and is found to be equal to the ratio of EMF and resistance offered by the external circuit. Now, this we have obtained using Ohm's law. What is Ohm's law? Ohm's law is V is equal to IR. Here we have EMF in the place of voltage. So I take it EMF. In the place of I, we have small I, and R as such. So if I cross multiply, I get the value of I to be equal to epsilon upon R. This is how we get the current flowing in the conductor AB when it is made to move in uniform magnetic field. I hope the video is useful. If you have any kind of doubt related to the topic, then you can put it in the comment section. Thanks for watching.